Hello, my name is Joshua Burns. This is my final project for ME 557, my application for computational analysis visualization using OpenGL. Again, my name is Joshua Burns. I am a senior simulations engineer at Honeywell. I work within the Advanced Engineering Simulations and Analysis division, where we do computational fluid dynamics and finite element analysis using high-performance computers. So as part of this team, I have led the visualization aspect, where we're developing tools using augmented and virtual reality to visualize our finite element and computational fluid dynamics analyses. From that point on, I've also become a technical fellowship student where I'm pursuing my master's degree in human-computer interaction, specifically focusing on data visualization. We want to be able to communicate big data, IoT, FEA data more effectively and more efficiently, coming out of our analysts to our engineers, to where the engineers trust that data implicitly whenever we communicate it to them, as well as being able to communicate results more effectively. The application I'm developing is a way to interactively visualize computational simulation results on a computer that is not built to graphically handle the actual visualization software that's built by FEA and CFD software companies. FEA and CFD software companies' software is incredibly expensive and hard to distribute out to every engineer in the facility, especially when you need a high-end computer to visualize it. So what I wanted to do was develop this application in a way where we could upload our FEA visualizations, just a single animation frame that would be able to effectively communicate to the engineer the results that they need to see. So I wanted to do that in a way that was interactive as well, so they can walk around and take a look at the FEA object, as well as be able to rotate it and take a look at specific aspects that they need to focus on. Here is what I've developed up until this point. So as you can see here, we are able to move the physical object, rotate it and translate it around using the W, A, S, and D keys. You can also see that we've imported a full object and be able to wrap a texture around it. So be able to rotate and translate as well in the object. And then you're able to use the spacebar to actually walk around the scene and be on a single plane. Using the spacebar to switch between these modes has been really great to use. So that way the person can focus on various aspects of the FEA mesh and take a look at stress risers or excess heat that might be in particular areas, so they can walk up and walk through if they need to. I've also implemented a shift key that allows you to quickly move around, and also implemented a bounds effect, basically not allowing the person to walk too far away from the mesh itself. So this came in real handy. So they can switch between and also rotate. Yeah, all right, so that's where we're at currently on the process. We've also been able to get the mesh imported effectively using an OBJ importer, and then texture that mesh with the results that came out of the FEA analysis. The most challenging part of this project so far has actually been importing the object file itself. So that took some learning on my part. Had to learn how to export a file type that I could then import into OpenGL from an FEA software. So using ParaView, I exported a world file type or VRML file type that encapsulates all vertex colors as well as all the vertex coordinates and the normals. And then I utilized 3ds Max to import that world file and then extract out the UVs and unwrap the UVs in a fashion that they would be on a bitmap file to easily import them into OpenGL. I also spent about a day there learning how to export or properly export an OBJ file format from 3ds Max, because I kept forgetting to include the texture and normal coordinates so that the OBJ file importer would effectively read the object file. Then I had to modify the OBJ importer within OpenGL to include the vertex texture coordinates within an object file. so that they can be utilized within the shader itself. So we can pass them on. And I also had to include the vertex normal coordinates, which are also within that object file. And the next piece, we had to modify the draw scripts to include those. And then last but not least, texturing. So we had to modify the, or had to import those textures, but I'm having some issues right now trying to get the textures to agree with each other. For some reason, my environmental map keeps overriding my object, the OBJ file texture. So trying to figure that out right now, as you can see within this image. No success yet, but working on it, going line by line, trying to figure out what is overriding what. This application has 4 major application components, including the complex object import, which we have already completed. The major issue that happens in that one is actually more to do with appearance and dealing with the texture mapping and the texture assignments to the memory and figuring out why one texture is overriding another. Still working on that. I need to work through that. The next piece being navigation. Having to work, we've already completed the majority of that with the first person navigation that we're having on with the mouse and the keyboard, as well as the included speed up function so people can walk around faster. And last but not least, the keyframe animations. So we already have triggered animations for rotation of the object and making it move around. I would also like to include some additional functions that I'll talk about in a little bit. So on the to-do list is definitely fix the texture mapping. I also want to introduce a floor so people can understand that they're walking around on a plane rather than having blank space underneath of them. And then have some bump mapping on that to give a little more texture and reflection. Working also on modifying the rotation on the object depending on the viewing angle instead of the model's actual X and Y axis itself. So I'd like to rotate it toward the person if I'm going to rotate along the X-axis, or if I'm rotating along the Y-axis, I always want to rotate in respect to the viewing matrix rather than on the model matrix itself. I also would like to include other animations on the object. Say if I walk up and I hit a key, it'll take off a mesh that has what it would look like in real life with a metallic mesh on it. And then another mesh that shows something like, instead of a heat map, I show a stress analysis. And then last but not least, I would like to document the code for later purposes. Is there any questions?